Hello friends, welcome back to the channel Learn with Art. Now the next topic to be discussed is linear data structure, that is linked list. Okay, so here I have listed some of the characteristics of linked list. So first is nothing but we have seen that is in case of arrays we have the contiguous memory locations of each and every element present in the array. Okay, so we will compare it with linked list also. Okay, so first we will see the first characteristic of linked list is series of nodes connected by pointers. Okay, so here it is the picture of, or we can say the structure of total linked list. Okay, so here this is called as node of a linked list and the node connected with each other, so this total structure is called as linked list. Okay, so here see linked list is nothing but a series of nodes connected by pointers. Okay, so this field is called as a pointer field and this is called as a data field. Okay, as we have seen that in case of arrays the elements are stored in a contiguous memory locations, means we have seen that the first element is present at 516 location in case of integer array, then second element will be present at 518 location. Okay, means these are stored contiguously. Okay, but in case of linked list the elements are not stored in a contiguous way, or we can call it as a non-contiguous memory locations of an element, because this element is present at one location and this second node could be present at some of the other location. Okay, again the same case happened with the remaining nodes also. Okay, also there is one advantage of linked list, that is dynamic allocation of memory is possible in case of linked list. Means suppose we want to add only one element in a linked list, then we have to assign only one node in the memory. Okay, so suppose we want to add more elements in the linked list, at that time we have to allocate memory for that remaining elements. Okay, so as and when required, the number of elements, the number of nodes could be added in the linked list. So that's why it is called as a dynamic memory allocation, and that is quite helpful for efficient use of memory also. Okay, but in case of arrays we have seen that we have to allocate the memory for all elements first and then we have to enter the elements one by one in the array. Okay, now next characteristic is sequential access to element as no indexing required. In case of linked list it doesn't have any kind of indexing, so if we want to access any element in the linked list, then it should start with the first node in the linked list. Okay, so the first node of the linked list is called as head node and the last node is called as a tail node. Okay, so suppose I want to traverse the fourth element, then I should start from the head node and from head I have to compare it with the data of each and every element, and then we can traverse up to any node present in the linked list. Okay, so for sequential access, for accessing any element we have to traverse from the beginning of the linked list. Okay, but in case of arrays there is indexing, so we can access direct element with the help of index also. Okay, so these were some of the characteristics of linked list. Now we will see the structure of the linked list. Okay, so this is the node of the linked list and here I have drawn the structure of node in the linked list, and this is I have considered here the singly linked list and this is the node from singly linked list. So the node from linked list contains two parts. First one is data part and second one is pointer part. Okay, so what this data part stores, so it stores the actual value, means actual element is present at the data part, and if we have the number of elements present in the linked list, then we have to store the address of next node in the linked list in the pointer field. Okay, so pointer field stores the address of next node in the linked list, because when we want to traverse from first node to next node, we must need an address, because this is not a contiguous memory allocation. So we have to know the address of the next node. That's why it is stored in the pointer field of the last node. Okay, so with the help of that pointer field, we can traverse the node in the linked list. Okay, now we will see how we can write the structure of a node in the linked list in case of C programming. Okay, so in node we have two parts, so I have to take structure in case of C programming. So I have taken here structure because these two are two different type of variables, and that I have to combine it. So that's why I have taken here structure and named it as node. Okay, so in structure I want two kind of field. One is data field, and suppose that data field stores integer elements, that's why its data is considered as int. If suppose you want to store character type of data, then you can have the char data type for data field. Okay, and next part is pointer field. So I have taken the pointer of node, because it is going to store the another node, and that node's data type is struct. That's why that's node's type is node. Okay, so that's why I have taken here pointer of node structure. Okay, and the name of field is what? Next. So this will complete the node structure of the node in the linked list. Okay, so this was related to the introduction of linked list. Now we will have the type of linked list. There are four types of linked list. First one is singly linked list. Already we have discussed the linked list that was related to the singly linked list only. Okay, so in case of singly linked list, we have two fields. One is data field and another is pointer field. Okay, so this is the structure of singly linked list, and this is the node structure of a node in the singly linked list. Okay, now next type of linked list is a doubly linked list. So in case of doubly linked list, we have two pointer fields and one data field to store data. Okay, now here we have two pointer field. One is for previous one node, one field stores the address of previous node, and second store the address of next node in the linked list. Okay, so in this doubly linked list, we can traverse the linked list in both direction. Okay, so that's why the name is given as doubly linked list. And here we will see the structure of node in doubly linked list. So here we have again the two pointer fields. So middle data field I have considered as integer field, so that's why int data, it stores the actual data, and the two pointer fields that are again of a type node, and these stores the address, that's why I have considered as pointer field. Okay, so one is for previous. In the first node we don't have the previous node, that's why this field will remain null, and in the last node we don't have the next field, that's why the last field is also null. Okay, this was related to doubly linked list. Now the next type of list is circular linked list. So as this is same as singly linked list, just the difference is what the last pointer field contains null pointer in case of singly linked list, because it doesn't have any next node. Okay, so whenever we will encounter at the last node, then we cannot go back to the first node. In case of singly linked list, that drawback has been removed with the help of circular linked list. Okay, so here the last pointer field store the address of its first node in the linked list. Okay, so here again we can traverse from last node to the head node or telnet to the head node. Okay, so the node structure is same as singly linked list. Only the last or tail node stores the address of the first node in the list. So here the last pointer null is replaced with the first node in the linked list. So the circular linked list has no beginning and no end. Then circular linked lists are more complex than the singly linked list to implement. Okay, because insertions, deletions, and other operations are little bit complicated in case of circular linked list as compared to the singly linked list. Okay, now we will see the next type of linked list, that is doubly linked list, doubly circular linked list. Okay, so in case of doubly circular linked list, it is same as the doubly linked list, just there is one difference, that is we have stored the address of last node in the linked list with the first node, and the first node will store the address of the last node. Okay, so the node structure is same as the same node present in the doubly linked list, and the circular doubly linked list does not contain any null previous field of the first node. Okay, because here the first pointer is replaced with the address of last node, and the last pointer field is replaced with the address of first node. Okay, so here also we can traverse in both the directions in case of doubly circular linked list, and this is quite complex than the circular linked list. Okay, so this was all about the introduction of linked list. Hope so you have understood what is mean by linked list, what is the structure of linked list, how the structure can be implemented in C, and the types of linked list. If you have any queries, then do comment, and if you like my videos, then never forget to share and subscribe to my channel. Thank you very much.